We need to solve a structural mechanics problem. We have a hollow steel tube with a known inside diameter that needs to support a given tensile load. Our task is to find the minimum required outside diameter so that the stress within the tube material doesn't exceed a specific limit. First, let's define our variables and list the known values. The outside diameter, d sub O, is what we need to find. The inside diameter, d sub I, is given as 100 millimeters, which we convert to 0.1 meters for consistency in our calculations. The tensile load, F, is 400 kilonewtons, or 400,000 newtons. Finally, the maximum allowable stress, sigma, is 120 meganewtons per square meter, which is equal to 120 times 10 to the power of 6 newtons per square meter. The fundamental relationship between stress, force, and area is given by the formula. Stress sigma equals force F divided by area A. For our hollow tube, the cross-sectional area A, which is the area resisting the load, is the area of the outer circle minus the area of the inner circle. This is calculated as pi divided by 4 times the quantity of the outside diameter squared minus the inside diameter squared. Now, let's substitute the expression for area A into our stress formula. We get sigma equals F divided by the quantity pi over 4 times d sub O squared minus d sub I squared. Our goal is to solve for d sub O. First, multiply both sides by the area term and divide by sigma to get pi over 4 times the quantity d sub O squared minus d sub I squared equals F over sigma. Next, multiply both sides by 4 and divide by pi to isolate the term with the diameters. D sub O squared minus D sub I squared equals 4 times F divided by the product of pi and sigma. Finally, add D sub I squared to both sides to get an expression for D sub O squared. D sub O squared equals 4F over pi sigma plus D sub I squared. We now have an equation for D sub O squared. Let's plug in the known values we listed earlier. D sub O squared equals 4 times 400,000. Divided by the product of pi, and 120 times 10 to the 6th plus 0.1 squared. Calculating the fraction gives approximately 0.004244. 0.1 squared is 0.01. Adding these two terms gives d sub O squared equals 0.014244. Remember, this value is in square meters. To find the outside diameter d sub O, we need to take the square root of this value. The square root of 0.014244 is approximately 0.1193. So, the outside diameter is 0.1193 meters. Since the inside diameter was given in millimeters, it's common to state the outside diameter in millimeters as well. Converting meters to millimeters by multiplying by 1,000, we get 119.3 millimeters. So, to summarize, for the hollow steel tube with an inside diameter of 100 millimeters to carry a tensile load of 400 kilonewtons while keeping the stress at or below 120 meganewtons per square meter, the outside diameter must be approximately 109